Ho, 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 Merry Hackmas. Today is day 14 of the Advent of Cyber 2023 challenge. Today's lesson is called Machine Learning, the little machine that wanted to learn. Just wanted to learn, just wanted to get some education. We're going to be talking about artificial intelligence and machine learning today. So let's hop on into it. The CTO has made our toy pipeline go wrong. I wonder if that's Mick Reedy or his replacement after being demoted. By affected elves at key positions in the toy making process, he was poisoned the pipeline and caused elves to make defective toys. McSkitty has started to combat the problem by placing control elves in the pipeline. These elves take measurements of the toys to try to narrow down the exact location of problematic elves in the pipeline by comparing the measurements of defective and perfect toys. However, this is incredibly tedious and lengthy process, so he's looking to use machine learning to optimize it. All right, we're going to talk about machine learning, basic machine learning structures and algorithms, and using neural networks to predict defective toys. I've already started the attack box. It's in split screen mode. Over the last decade, there's been a boom in AI and machine learning systems. In the last couple of years, the release of ChatGPT has taken the world by storm. However, some of these systems actually work is how they work is shrouded in mystery, leading to a lot of snake oil sales tactics. In this task, you will get a glimpse into the world of machine learning to help demystify this incredibly interesting topic. We'll create our very own neural network that can be used to detect defective toys. Zero to hero in AI. Before we create our own AI, we need to know some of the basics. First, let's discuss two terms. AI is used in broad strokes in the world, often incorrectly. AI can't just be a bunch of if statements. A better term to use is machine learning. Machine learning takes the process used to create a system that can mimic the behavior we see in real life. This is because there is intelligence in real life and its structures. The field is incredibly broad, but here are a couple popular examples. There's the genetic algorithm. Machine learning structure aims to mimic the process of natural selection evolution. Particle swarm aims to mimic the process of how birds flock and group together at specific points. Neural networks is by far the most popular and aims to mimic the process of how neurons work in the brain. These neurons receive various inputs and they are transformed before being sent to the next neuron. These neurons can be trained to perform the correct transformations to provide the correct final answer. There are many machine learning structures. If we click on here, it'll probably take us to a page where we can buy a book. Interesting. This is where I started. So whoever designed this task read that book first. And whoever designed this task probably knows way a whole lot about AI and ML. First on our list of basics is this cover neural networks learning style. There are two different learning styles, main learning styles to start with. Supervised learning. Supervised learning is We asked the neural network to give us an answer, and we provided feedback on how close it was. In this way, we're supervising the neural network as it learns. However, to use this style, we need a data set where we know the correct answers. This is called a labeled data set, as we have a label for what correct answers should be given the input. In unsupervised learning, we take the hands off and let the neural network do its thing. While this sounds strange, the main goal is to have the neural network identify interesting things, and quotes, interesting things. For example, simply looking at an image and being able to tell what color it is. But if someone was to ask you, why is it that color? Would you have a hard time explaining the reason? Humans can see up to 3 dimensions. Neural networks have the ability to work in 4 greater dimensions to see patterns. In this task, we'll focus on supervised learning. It's an easier style for learning the basics, including the basic neural network structure. So I guess we're getting into the structure now. So a neural network consists of neurons and they're connected like the animation shows. So you have these metrics here and they're going into the input. And the input is feeding a layer, which is feeding the other layer, which both these layers are hidden. And I guess this is the output. And that is exactly what's going on here. So the input layer is the first layer, and it takes the data in and passes it to one of the hidden layers, which could pass it to another hidden layer, and that could repeat, or it looks like the first hidden layer could probably just pass to the output. There's no set limit on the number of hidden layers. It looks like it just has to be one or more. Let's zoom in, see what the hidden layer is doing. We'll simplify the math here. The node is receiving inputs from nodes in the previous layer, adding them together and sending the output to the next layer. However, a little bit more detail is important. Inputs are not directly added. Instead, they are multiplied by a weight value first. This helps the neural network decide which inputs should contribute more to the output. So it's a weighted, like, average type deal. The additions output is not directly transmitted out. Instead, the output is entered to what is called an activation function. In excess, this decides if the neural node will be active or not. It does this by assuring the output, no matter the function, will be a decimal between 0 and 1, or between 1 and -1 and 1. So I guess that's what the trigonomic function, I thought I saw, yeah. So when you're dealing with that, that helps confine the results in between the range of -1 and 1. Feed for loop is how we send data through the network and get an answer on the other side. Once our network has been trained, this is the only step. So a trained network only does a feed for loop. At this point, we stop training and simply want to answer. To complete one round of the feed forward step, we have the following. Say animated, yeah, okay. So it normalizes the metrics and feeds into the input. So it looks like if it rounds to 0, then it says it's defective. Okay. Normalize the inputs. We feed the inputs to the layers of our nodes into the input layer. Once normalized, we can provide one data entry for each input node. Propagate the data through the network. At each node, we add all the inputs and run them through the activation function to get the node's output. The output becomes the input for the next layer. We repeat this process to get our network's output layer. Then we read the output from the network, and the answer is going to be a decimal between 0 and 1. And we'll round it to get a binary answer from each output node. So it's highly reliant on averages. And at least in this scenario, it's highly reliant on averages. And so that's cool. So it's really guessing. It's really guessing. So I suspect that there will be some false positives and maybe some false negatives coming out of here. Back propagation. So when we're training, the feedback loop is only half. The feed forward loop is only half the process. When we receive the answers, we tell it how close it was to the correct. And this is the back propagation step. So the back propagation step only helps when you're training. And when you're training it, you feed it the test set that has the answers. So once it figures out the answer and it looks at the answer it has, it can, all right. And from there, it can update the weights and, okay. So when you're testing it, the more it's wrong, the more it becomes right. It's still kind of guessing. All right. Data set splits. Let's use an analogy to explain this. Let's say your teacher constantly tells you 1 plus 1 equals 2 and 2 plus 2 equals 4. But in the exam, your teacher asks you to calculate 3 plus 3. Have you just learned what the answer is? Did you learn the fundamental principle required to get the answer? In short, you can obtain it yourself. You can overtrain yourself by learning answers instead of learning the required principle. The same thing can happen with neural networks. Overtraining is a big problem. We're training them with data we know the answers, so it's possible for the network to simply learn the answers and not actually how to do the calculations to get the correct answer. Combat this, we need to validate our neural network is learning the process, not the answers. This tells us that when we stop our learning process, we perform this validation. We split our data into 3 data sets. So we have training data. This is the largest set. We use it to train the network. This is 70-80% of the data set. We have validation. We use this to validate the training. After each training round, we send this data through the network to determine its performance. If the performance starts to decline, we know we are starting to overtrain and should stop. Usually this takes 10 to 15% of the usual original data set. And then there's testing. This data set is used to calculate the final performance of the network. The network won't see this data at all till we're done. Once it's complete, we send through the testing data to determine the performance. This is normally 10 to 15%. Okay. We'll put it in all together. Start the machine, show it in split screen after 2 minutes. You find the files you need on the desktop in the neural network folder. Okay. So we have a Python program. Okay. So data set train is okay. So we're not using trainer and validation data. We're using this for training and validation. And this is our test data. All right. So it looks like we're going to be filling out the detector.py. Let's cd to the desktop. It's in the folder neural network. Okay. I'm going to open up VI. Okay. We use the Nupi and Pandas, which, if you've been following along, we talked about in day 1 or day 2. I'm pretty sure it's day 1 though. So we have a function to split the data. This function encodes the text to integers. Scalar normalizes, encoder encodes the data to integers. MLP classifier. This is our multi-layer perception neural network. These are the color labels we will convert to integers. So we have an array. Training data, you're going to read the CSV and all right, so it's going to read both the files. It's going to instantiate an encoder, a label encoder, and it's going to it's going to take this array and it's going to fit it in. Transform. Okay, it's going to encode those strings as integers. And then we're going to make an array. Okay. So it's going to be one for the making a variable for the defective stuff, but then we're making one just for the data. And for the testing, we're just making an array for the data. All right. We're going to create data sets. So it looks like we're going to be Typing in some code here. All right. So first we need to normalize the data. Caplux. Matter of fact, I could type this all out, and I'm not a slow typer, but at the same time, I am prone to making mistakes like everyone else, and um, and we train the data. So, okay. Then we classify the data, classify training code. So let's see, solver. This is the algorithm to update the weights. This is the value used for the regular. So I forget sometimes TryHackMe is a British company. In America, we would spell that with the Z, regularization. I'm like, wait, that was throwing me off. So this is 10 to the negative fifth power. So 1/10,000. Uh, hidden layer sizes. We'll have two hidden layers with 15 nodes each. This is the max number of times we can train before it's forcibly stopped, which is 10,000 too. All right. So, ironically, the function for training is the fit method. That's interesting. Uh, I could probably type that out faster than I can. Mm. Oh, it's lowercase. And the y predicted predict validate. No, that's capitalized. All right. Mm-hmm. So when you execute the script, predictions are slightly faster than trained. This is why neural networks can actually be used in real life applications, as the prediction rate is incredibly fast once the network is trained. We can determine the accuracy of our classifier by comparing the two arrays with the following codes. All right, so this code down here. Okay, so once the training is complete, it's going to print out some information and tell us what the accuracy is. One last step. We're going to ask the neural network to make predictions on the testing data that was not labeled by the else with the following code. Is that the end of the file? Insert classifier testing prediction here. Okay, so we're going to put it here. All right, we got to save it, exit, colon, WQ, exclamation point for right quit. And the exclamation point means that it's not going to give us a prompt to hit yes or no or anything like that. All right. Python 3 detector.py. We have a bug. Let's see, line 45. Line 48. Right here. Wait. That's not a line. Insert data split code. Did I glance over a line somewhere? Yeah, I did. All right. Insert with the I. Let's just pass that. All right. Hopefully I didn't overlook anything else. Right quit. Uh-oh. Oh, wait. Quit. Line 71. did copy that in. Ah, I should have just copied and pasted it instead of. So it's training, and if it's gonna run up to 10,000 times, like the code said it could, then hopefully it don't take too long. Mhm. So it's gonna save the predictions to a file. We're gonna upload to this website. So while we're waiting for it, start getting the website up. I'm pretty sure. Oh, okay. 5 minutes later. Mm-hmm. If your accuracy is above 90%, you will be awarded the flag. If your neural network's not able to reach 90%, run the script again to retrain and submit new predictions. Usually within 2 training rounds, you'll reach 90%. This does, however, raise the question of why neural networks' accuracy fluctuates. The reason for fluctuating is neural networks have a randomness built in. The weights for each of the inputs are randomized at start, meaning the two neural networks are never the same. Similar how different brains might learn the same data differently. To truly determine the accuracy of your neural network, you have to train it several times and calculate the average accuracy across all. Several factors. Oh, look at that. We got over 90%. Several factors might also influence the accuracy of the network, the quality of the data sets. In machine learning, there's a term called GIGO. That's not just machine learning. That's not just machine learning. Garbage in, garbage out. If you have garbage data, you're gonna that's anything in tech, especially when it comes to outdated documentation and things. You always want to make sure you throw away the trash. Because yeah, I'm not going to go into my career horror stories of fake news and documentation of things of ghosts of Christmas past and such. AI isn't this magic thing fix every problem. And machine learning structure is only as good as the quality of the data used to train it. Without good data, we wouldn't be able to receive accurate output. Uh, Machine learning, or AI as it's called in the world out there, has Real life applications, as shown in the example, they're incredibly at finding complex patterns in data and performing predictions. So large data sets with large accuracy. While humans can often do the same, the sheer amount of data and predictions could be overwhelming. They're incredibly good at anomaly detection. If you provide a well trained ML structure with thousands of data points, it will be able to discern outliers for you. Uh, and they have the ability to learn complex patterns. They can be used for authentication applications such as biometric authentication. They can predict whether a person's fingerprint or iris matches the template that's been stored to provide access to buildings. Cautions. Caution should be observed for two reasons. Machine learning, like humans, is imperfect. There's a very good reason why the answer provided is a prediction. It's impossible to get 100% of the predictions to be true. For this reason, you should remember AI isn't a silver bullet for our problems. It will never be perfect. It should be used in conjunction with humans to play to each of the strengths. The same power that allows ML to be used for defense means it could be used for offense. We will show you in tomorrow's task. ML structures and AI can be used to attack systems. We should therefore always consider this a potential threat to the systems we create. All right. That's one way to pump me up for tomorrow. Tell me that we're going to use AI to hack stuff. Okay. Um, I think this is our file. Here. Load. We got our a flag here. We got our flag, and we're going to answer these questions and get ready to hack some more tomorrow. Paste this. What's the other time for artificial intelligence? There, the subset, the teach. That is machine learning. What mimics the process of natural selection and evolution. Um, I read it. What was it? It was genetic algorithm. Genetic algorithm. What is the name of the learning style that uses labeled data to train supervised learning? The layer between the input and output layers is the hidden layer. The name of the process used to provide feedback. That was called backlogging, back propagation, back feed, back propagation. Back propagation. All right. And we have all the questions answered, and that is the end of day 14. I'll catch you again on the flip side tomorrow. Thanks for tuning in. I hope I provided any type of feedback or said something that helped someone today, or in any way or any form. And see you tomorrow. Peace.